This is Ishan, and in this presentation, I'm going to talk about my work as a data science and business analytics intern at the Sparks Foundation. So, here, my task was to develop a model to predict the final score in percentage of any student based on the total number of hours that he or she studies for per day. Here, as you can see, I have imported a few libraries that I'll need to get the desired output. The libraries are Pandas, NumPy, Matplotlib, and Seaborn. The raw data to be used was imported from the mentioned URL. After getting the data with data.shape, we will learn about the shape of the data, which in our case is 25,2, which means that the data that we are using is filled across 25 rows and 2 columns. Under data.describe, uh, we will learn about the count, mean, standard deviation, minimum and maximum values present in a dataset. The data.info tells us about the data types and the presence of an null value in the dataset. Here I have also plotted the received data in the form of a scatter plot where x and y axis represent the hours and scores respectively. From the scatter plot, here it is quite evident that the relationship between the two variables is linear, which means the scores of a student are directly proportional to the hours that the student studied for per day. This dataset can be validated using the correlation coefficient methods such as Pearson and Spearman to get a detailed account of its linearity. Here, as you can see, we get a coefficient value of about 0.97, which is almost equal to 1. This testifies for the positive relationship between the hours and the scores and tells us that for every positive increase in the number of hours put in by the student, his or her scores will see a corresponding positive rise. These are the distribution plots for both the variables, where the variations in the values of both the continuous variables can be seen. The model that we'll be using here is the linear regression model. Now, a linear regression model is basically a regression model that estimates the relationship between one independent variable and dependent variable using a straight line. Here the data is divided into two sections. Roughly 80% of the data is used for learning and the rest 20% is used for testing. For the scatter plot obtained from our data, it is difficult to obtain a straight line under which all the points are covered. So here scikit-learn produces a line in such a manner that the sum of difference of predicted values and actual scores is kept to minimum. M and C are the two outputs, which are the slope and intercept of the obtained line respectively. Here we can see the target values which are already present in the dataset and the predicted values that we obtained from the model. We have also plotted a distribution plot for the target and predicted values. The difference also is found to be quite close to 0, and it is between the range of -5 and 5. This testifies for the efficiency and accuracy of the regression model. So finally, what would be the predicted score of a student if he or she studies for 9.25 hours per day? So we get any student who studies for 9.25 hours per day might score around 91.56%, which is a predicted score. For the evaluation of this model, two performance metrics were used: mean absolute error and R-square score. The R-square score can range from a negative value to a positive one, depending upon the efficiency of the design model. Here we see an R-square score of 0.97, which can be considered as a fairly good R-square score and tells us that the model is successfully predicting the score based on the given data. Thank you for listening.